Okay, so we're going to introduce probability distributions. So a probability distribution is a summary of probabilities for the values of a random variable. So it should describe all my possible outcomes and the probability of all possible outcomes. Here's just some notation. We're going to be using this throughout. You should get pretty used to it. So the probability that my actual outcome is equal to this particular outcome, and then you can give your probability. Here's an example. So this is a capital X, and so this is my random variable. This is a score when a fair dice is rolled. This is going to be a discrete random variable because when you roll a fair dice, you can only get one of 6 possible outcomes. It's not continuous. It's just either going to be 1, 2, 3, 4, 5, or 6. So there's different ways that we can describe my probability distribution. There's 3. We can describe it using a probability mass function. And then here's how we write this. So we have the probability that x, that's a capital X, so the probability that the score is equal to some particular value of x is equal to 1 over 6, when my particular value of x, this thing here, is 1, 2, 3, 4, 5, or 6. So what that means is we can substitute any one of these small x values into here, and the probability that my dice roll is equal to 1 is a sixth. The probability that my dice roll is equal to 2 is a sixth. The probability that my dice roll is equal to 3 is a sixth, and so on. And so this sentence here, this line, is going to accurately describe the probability for any one of my numbers on my dice. Next, we can have a look at a table. So there's another way of describing this. So I have my value x, this is my dice roll, and then the probability that my dice roll is equal to this value. So the probability that my dice roll is equal to 1 is a sixth, the probability that my dice roll is equal to 2 is a sixth, and so on. And then we can also use a diagram, like so. So along this axis here, we have the probability that x is equal to x, and along this axis we have small x, so each of my individual dice values. So the probability that my dice roll is equal to 1 is a sixth, 2 is a sixth, and so on. And then the length of these lines here will correspond to the probability. This is actually a discrete uniform distribution because all of my probabilities here are the same. If we had like a spinner or something where it was more likely to get 3 or more likely to get 4, you might find the heights of these bars vary. Let's look at an example. So, slightly more complicated than my dice, I guess. We're going to throw 3 fair coins, and first of all I want to list all the possible outcomes. So we could get heads, heads, heads. I could get heads, heads, tails. I could get heads, tails, heads. I could have tails, heads, heads. I could have heads, tails, tails. Could have tails, heads, tails. I could have tails, tails, heads. And then finally, we could have tails, tails, tails. So they're all the possible things that could happen when I throw 3 coins. And then I'm defining now my random variable x, and that is the number of heads when the 3 coins are tossed. And then now they're asking me for a probability distribution of x, and they want me to do that as a table, and then as a probability mass function. So let's first of all start off by drawing my table. So at the top here I'm going to have lowercase x, and then at the bottom I want the probability that x is equal to x. So small x here is each individual thing that could happen, and then I want the probability that my number of heads is equal to this. So how many heads could we get? Well, we could have tails, 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 in which case we would have no heads. So it's going to be 0. I could have 1 head come up in one of these occasions. So that's 1. I could have 2, like those here. 2. Or I could have all 3 of my coins rolled to up at being heads. And then what's the probability that when I throw my coin 3 times, I'm going to get no heads come up? Well, that only happens once in this occasion here. So this is going to be one way that we get no heads out of 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. The probability that I get one head, well, we can see that we get one head here, here, or here. So 3 different ways to get 1 out of 8 again. And then 2, when I get 2 heads here, here, or here. So again, that's 3 ways to get 2 heads out of 8 possible outcomes. And then the probability of me getting all 3 is just going to be 1 out of 8. Like so. And so now here, this table describes all my probabilities for getting the number of heads when 3 coins are tossed. And then I can also write this as probability mass function. So I've got the probability that my random variable is equal to some particular outcome. It's equal to, and then if I look here at my table, so I've got 1 out of 8 here and 3 out of 8 here. These are the 2 different probabilities that I can have. So I can condense these down instead of having to list all 4 out. So we either have 1 out of 8, or I have a probability of 3 out of 8, or I have a probability of 0. And the probability of 1 out of 8 happens when x is equal to 0 or 3. And then the probability of 3 out of 8 happens when x is equal to 1 or 2. And then I get probability of 0 for x being any other number, because it's impossible that I get, say, 4 heads, because I'm only throwing the coin 3 times. And there's my probability mass function. So we have another example here. Bag contains 2 discs with the number 2 written on them, and 2 discs with the number 3 written on them. We're going to draw a disc at random and then write down the number. And then we're going to put the disc back in the bag and draw a second disc, and then again write down the number. And then we're being asked to list all the possible outcomes. And then we're told the discrete random variable x is defined as the sum of the 2 numbers. So if we took out the 2 and then took out 2 again, then the sum would be 4, and so on. And then they want us to write down the probability distribution of x, so the sum of the 2 numbers, as a table and as a probability mass function. So pause the video now and see if you can list all the possible outcomes, and then do the table and the probability mass function for this discrete random variable. Okay. So here's what your different outcomes should look like. So you could take a 2 and a 2, a 2 and a 3 and then a 2, or a 3 and a 3. And then when we start to add up these 2 numbers, and then note the total, then the totals here could be 4, 5, or 6. And then you want the probability that you get a total of 4, 5, or 6. And we could get 4 just one way here, so 1 out of 4. We get 5 2 ways, like so. So that's 2 out of 4, or a half. And then we get 6 one way, like so. So that's 1 over 4. And then here's your probability mass function. So you either get a quarter or a half, and then there's your various x values. Okay. So we have different types of probability distributions. Probability distributions for discrete random variables, and probability distributions for continuous random variables. So discrete random variables are things like rolling your dice, choosing a card from a deck of cards, because there's a finite possible outcomes here. Continuous random variables are things like distance and time. So for instance, if I wanted to know the height of a student randomly selected from a class, then that would be a continuous random variable, because height is a continuous variable. Some probability distributions. So binomial distribution, this is the one we're going to look at the most. These are for discrete random variables. And this here is just notation, so this is how we lay out our probability distribution. So x is our variable, so for instance like the roll of the dice or whatever, and then we have this little squiggle, a tilde, and then we write b, so this tells your reader that you're using the binomial distribution. And then you, in brackets here, you have some information that you need in order to set this up. So n is going to be your number of trials, and p is the probability of success. So for instance, if I was rolling the dice, and I'm rolling it 5 times, and I want to see how many ones I get, for instance, then my number of trials would be 5, and my probability of success would be 1 over 6, because the probability of me rolling a 1 is 1 over 6. Normal distribution. So this is for a continuous random variable, so something like the height of your students in your class. And then to set this up, you want x to be your random variable that you're looking at, and then another tilde, and then we write an n to tell our reader that we're using a normal distribution. And then the two values that we need to set up our normal distribution are the mean, so for instance the average height of a student in your class, and then the variance, so how spread out the data is. And then a Poisson distribution, this is for discrete random variables, and here you need your variable, your tilde again, you write PO to say that you're in a Poisson distribution, and then your lambda number here is going to be your number of occurrences. So for a Poisson distribution, for instance, you might have the number of people that go into a shop within the space of an hour, and so then that would be the number of occurrences there. In the next few videos, we're going to be looking at binomial distribution, so we're going to look at this one in quite a lot of detail. We do not cover the normal or the Poisson, and these are just 3 examples. There are lots of other sort of types of probability distributions, but you may need to do your own research into these depending on what your coursework questions are that you get. But this is the one that we will look at next. Okay, thank you very much.